yet why that's important. That's what the second half of today's lecture is about. But, are we in agreement? The whole reason the thermal wind relationship worked was because one side of the front was cold and the other side was warm. Remember the whole argument about thickness and how one side was closer to the ground, the other side was farther up, etc. Well, that only worked because one side of the front was cold and one side of the front was warm. We don't have that anymore. On our occluded front, both sides are cold. Which means no thermal wind relationship. Which means no jet stream. So once you have an occluded front, we don't have a jet stream above it anymore. When we were at earlier stages in the life cycle of the mid-latitude cyclone, I'm just going to throw this guy up for example, because of the thermal wind relationship, sitting on top of these fronts, there was some kind of jet stream, the mid-latitude jet stream, or the polar jet stream, depending on which page of the book you happen to be reading. They use both terms. Sitting up here on top of there was a jet stream. It might be here, exactly where, it doesn't matter. But guess what? Once we have an occluded front, that doesn't happen anymore. Well, no, that's not true. There's still a jet stream sitting on top of the cold front and on top of the warm front, but it's not sitting up on top of the cyclone anymore. And as we're about to see, where that jet stream is with respect to that cyclone is the business as to why the cyclone was there in the first place. But we'll get to that in just a few. Again, it's like talking about chickens and eggs. Meanwhile, though, the cyclone is still alive. I mean, it is still moving. It still has air that is flowing around it in a counterclockwise way. But the problem is that occluded front is only going to get longer and longer with time. And I've lost my last slide. If we come back and look at this occluded cyclone a few hours later, what's going to happen? The cold front is still moving, the warm front is still moving, but the cold front is moving faster. It will catch up with more of the warm front and make more of the warm front an occluded front. And so if we come back and look at this guy a few hours later, he's going to look like this. He's got more of his front occluded. Still got a cold front and he's still got a warm front. But notice that the occluded front got even longer. And if we come back and look even in a few, another day or two, the occluded front is even longer. I like to think of it as kind of like a zipper. Okay? Once you start making the occluded front, it sort of zips up along the length. It just gets longer and longer as the cold front and the warm front occlude. Just like, for that matter, the teeth of a zipper occlude, right? They fit together just right. If they don't fit together right, you can't zip your zipper. At this point, the cyclone is dying for reasons we're going to see in just a few minutes, and we'll get weaker and weaker until we just can't even find it on the map anymore. And so that the occluded front itself is not that exciting. The occluded front itself is not really all got that much jet stream going on above it. It doesn't have that much weather going on associated with it. Pretty soon we just don't care anymore. The occluded front, the cyclone has died. We can't find it anymore. So our cyclone goes through a life cycle and looks different at different parts of its life. It started off along some simple little stationary front, and once the processes of cyclogenesis got going, we started having a cyclone, an area of low pressure develop on there, but the rotation around that cyclone kicked those air masses, the cold air mass got kicked to the south, the warm air mass got kicked to the north. With time, we had an open wave, but eventually that cold front, which is moving much faster than the warm front, starts to catch up with the cold front, or the warm front, and we start getting an occluded front, which is only going to get longer and longer as time goes by. More and more that cold front catches up with that warm front, and we get a longer and longer occluded front, and our cyclone begins to die. We can have lots of cyclones then that look pretty similar at different stages of their lifetime. Let's talk about what cyclones look like. What cyclones look like at different stages in their life. And the classic diagram that we always draw looks something like this, with a low, a cold front, and a warm front. You can kind of think of them as looking kind of like legs coming off of that low. Let's see here. I have someplace over here on the bulletin list. so I don't miss anything. I can't find it. I'm not sure. Okay. So, look what's going on here. We've got counterclockwise rotation going on around that cyclone. The fronts meet in the center of the cyclone. We usually draw it with a little gap in between there, just so there's room for the L's, but there's no gap. In other words, for example, you're not going to find a cyclone that looks like this. What's going on here? Right? Where are there gaps? No gaps. What? Like is air leaking through here? Help me out. What's going on? There's no gaps in your fronts on your cyclone, okay? They're continuous. They meet up there. Yeah, I know I drew it a little sloppy. They don't quite meet up here. That's no problem. I mean, that's just how I drew it. I made room for my L. That's all. So you don't want to find any gaps. Your cyclones will always look so that the fronts are fairly smooth. Notice how like they're pretty much a little straight, slightly curved line. You'll never find a cyclone that looks like this. This crazy front. Okay? If you watch the weather, and I guess by now you're probably watching the Weather Channel a lot, you notice that the fronts are always drawn as pretty nice straight lines, more like this, and not like this. Okay? There's always, especially like upper division atmospheric science courses, there's always students who want to make their fronts really complicated. No, make them relatively smooth. Your fronts should, when you're looking at fronts then, you should always keep in mind the rotation around the cyclone. I mean, at first blush, this doesn't look so bad. But wait a minute, the rotation around a cyclone goes this way. Why would there be cold air, why would the warm air be moving, right? See how they got the fronts pointing the wrong direction? So this is backwards. Fronts don't cross. Okay, so for example, don't try to draw like cold front, warm front. They don't cross like anything like that. What would that be then? I don't know. This is continental polar, and this is maritime tropical. Why would there be maritime tropical air behind the cold front? It's very confusing. So this is they don't cross. Let's see here. Okay. Fronts always, I think I'll skip that. Okay, so for example, remember the quiz we did one semester where I had all these little drawings of fronts? And I had them mark which ones of these looked realistic, and then afterward we did it kind of as a group on the key up on the board. So for example, this is a good looking cyclone. He's got a low pressure system in the center. He's got cold air coming from the north on his west side. He's got a nice warm sector with warm air coming up to the north on his east side. That looks good. What's wrong with this guy? I apologize that he's already marked off. What? Someone said something? He's a high pressure system, right? High pressure systems are the air masses. They're what's back here on either side of the fronts. The center of the cyclone itself needs to be low pressure, not high pressure. Again, I apologize that this is already marked out. What was wrong with this one? Yeah, you got warm front coming from the north. How's that supposed to work? You've got cold air front coming from the south. That isn't going to work. This one, I'm sorry, what? What did you say?
That's just direction.
Yeah, so see how there's a warm front here? And the semicircles are pointing in the direction the warm air is supposed to be moving, but how would warm air be coming from the north? And how would cold air be coming from the south? See how the blue teeth are